Let's take a look at a hypothesis test involving a difference of proportions from our actual US history. I would suggest to you that you maybe hit pause on this video right now and refamiliarize yourself with the Vietnam Draft Lottery question. We looked at this before spring break. I recall when we were drawing graphs of things, box plots, that's what I was trying to remember. But, so we've looked at this. I would suggest you read take a look at, say, the next 3 slides here as far as the setup of the Vietnam Draft Lottery and the fact that it was an actual distribution. You guys remember we all looked up our own birthdays to see if we would have been drafted and that sort of thing. This has been around for a long time, but a lot of people looked at the numbers back in the day, and they still do, and a lot of people suspected that people born in December had a much greater chance of being drafted. So the question was, if you were born in December, did you have a higher probability of being drafted as opposed to not being born in December? So we're basically comparing the young men who were born in December, those that had December birth dates, with those that did not have a December birth date. All right, so let's call population 1 young men who had December birth dates, and number 2, not born in December. And so the question is the percentage of draftees who were born in December, represented by percentage 1, is it significantly higher than those who were not born in December? All right, so that would be our original alternative hypothesis. The fact that December had a higher draft percentage than basically the rest of the year. Once again, much like the previous 2 examples, if we subtract over the P2 and do a little bit of algebra manipulation to this, this becomes P1 minus P2 is greater than 0. Again, if you take one percentage minus another and you get something bigger than 0, that means the first one was higher than the second one. And that's the basic question here. All right, so we've got that set up. The null that would correspond to that would be that there is no difference between the 2 percentages. It doesn't matter what month you're born in, your probability of being drafted is the same. All right, there's no difference. So, we've established our test statistic here. And this will be the same for all of the questions on that assignment. Just write that in ink on every one of them. Test statistic, you'll get that point for sure. Z, all right, so that would be your bell curve, your standard normal, with 0 in the middle. And the alpha value, we've talked many times, can be anything we want it to be. But let's suppose the person doing this decided they wanted to use 4% significance. And it could be anything, 1%, who cares? But again, since we have a greater than alternative hypothesis, that will go in the upper tail. We're building off of the previous examples. So again, I highly recommend that you watch these in sequence because again, this has behavior very closely related to the ones that we've enjoyed previously. The steps. This is our 3rd set of hypothesis test questions, and so again, given the fact that this was a greater than alternative, this is on the upper tail. Z, as I've told you many times, you're tired of me by now, I'm sure, but this particular Z table that I've learned seems to click with the vast majority of people I've done this with. Middle sliver, 46%. Upper half of the curve, 0.5, minus 4% tail, 46% middle sliver. This is again the middle sliver table. So 46% in the body of that table that I uploaded to you would be closest to the 4599, and that's a z-score of positive 1.75. So I'm hopeful that all the mechanics of setting up the rejection region and the rule have really started to click. So won't we reject the null hypothesis if the z-score we get in a little bit turns out to be greater than 1.75? So there you go again. alternative, 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 it all hooks back. Greater than, upper tail, greater. All right, woo! Everybody get out your calculators now. Time to do the computations. So this is where people actually looked at the draft numbers for all these birth dates, and they compared December, which is this last column out here, to the entire rest of the year. And you could just sit down and brute force, count them up. So here we go. Let's take it one by one. P hat 1 would be the percentage in our sample who were born in December and got drafted. And it says right here, of the 31 birth dates in December, 26 got drafted. So you had a probability of 26 out of 31. Now I realize that's a nasty decimal, so just like the one we saw earlier, we're going to leave it in fraction form, but just for perspective, that is roughly 84%. So if you were born in December, you had about an 84% chance of being ultimately drafted. The non-December birthdays, of the 335 non-December birth dates, 169 got drafted. So 169 out of 335. That's again a nasty decimal, I'm pretty sure, but just for perspective, 169 divided by 335 is roughly 50%. So keep in mind, that's about 84%, that's about 50%. Seems like that's a pretty big difference, doesn't it? We're seeing if it's a very big difference between them. All right, P bar would be the pooled percentage. That would be to add up, basically again, you're adding up the two numerators and adding up the two denominators of these percentages, pooled percentage. What's your probability of being drafted regardless of the month you were born? You're putting the entire year together. So that would be the 26 plus 169 over 31 plus 335. All right, so 169 plus 26, why do I have to have a calculator to do that? 195 out of 366. See, there's 366 total birthdays. I want to remind you, they counted leap day. They put February 29 in there. So of the total 366 birth dates a person could have, 195 of them got drafted. And just for perspective, that's roughly 53%. So we have that. Q bar would be 1 minus that. Remember, P's and Q's are complements. And 1, in order to get a common denominator, would be 366 over 366. So 366 over 366, which is 1, minus that, would equal. And these would be the young men throughout the whole year, all birth dates. 171 out of 366 did not get drafted. All right? So those are pooled. You're putting the December and the non-December together into one group and pooling them together. So again, I have to go off camera here a little bit here. I'm standing on the edge, but I'm going to write those numbers down so I don't forget them over here off to the side. That's what I'm doing in case you're wondering. And I got to do that to make room here. All right, so you got your P, hit pause anytime you want, right? I mean, it's a lot better in class because you can pause me anytime you want, right? Go get a snack or whatever you want to do. All right. Just quit listening to me if you want. Okay, Z equals, here we go. P hat 1, that'd be the 26 out of 31 December birth dates that got drafted, minus P hat 2, 169 over 335, minus 0. That's the assumption. See, these are, the hats are percentages from sample. Those are population, right? So we assume there's no difference. That's what scientists do. They assume, nah, there's nothing fishy going on. Let's give that the benefit of the doubt. All right, P bar, 195 over 366, I'll remind you. Q-bar, 171 over 366, all over, sample size number 1, 31. 31 birth dates in December. 31, N1, right? N1 is the number in the first population. Plus 195 over 366. I hope you guys are halfway through punching the numbers out. And then sample size number 2 would be the 335 non-December birth dates. Crunch, crunch, crunch. All right, this is where it's exciting. Drum roll. Everybody sits there and pokes buttons. You know, peek if you want to. I don't know. You've heard me say this too many times. Okay? So, crunch, crunch, crunch. I know that's snotty. I'll just tell you, previous students, you can blame it on them. They told me, yeah, I'm good from here. Mr. Sports Coop. I don't know. But anyway, it turns out that that value of Z, as you see on the next slide that was uploaded to you, should be 3.568, something along those lines. And so there it is. And you will note that that number is indeed in that upper tail. 3.568 is beyond the 1.75. If it's beyond the 1.75, we're going to reject the null hypothesis. That's why that's called a rejection region on the picture. And so if we reject that null hypothesis in favor of the alternative, so reject the null hypothesis, and doesn't that essentially mean that if you were born in December, you did have a significantly higher probability of being drafted as opposed to if you were not born in December? So again, at the 4% level of significance, the percentage of draftees born in December was significantly higher than the percentage of draftees not born in December. And so there's all kinds of conspiracy theories about this and all that. I'll let it go at that. But that would be the way a statistician would investigate that particular discrepancy, let's call it. Okay, so that should hopefully enable you now to do assignment 27, 28. I'll again tell you 3 questions, 8 points apiece. So just go through, and the further you can get into it, I hope you get the whole thing right, but potential of 8 points on each question. All right, good luck to you.